continue talking. Okay, so basically for this lecture, I'll be talking about, or I'll be giving a brief introduction about my topic, the course, and some revision, because I noticed that I think most of you guys have set for my course last year, or probably last semester. I think it's last year. SID2004. Am I correct? Because I think I've noticed a few common names, even though I might not know you personally, but your names are very familiar. Okay, so if you have, then it's good. If you haven't, then you need to focus more. Because basically what I'm going to talk about, or pretty much throughout the semester, the special topics that I'm going to talk about is basically involving peptides and proteins. But as compared to when you are doing your course in SID2004, okay, that course is pretty much an introduction to peptides, the structural, some synthesis related to chemistry. But for this course especially, it will be focusing more on the application of those technologies. Okay, so we've learned a lot about peptides. I'm hoping that you'll be able to at least understand what I'm trying to convey to you guys. Now, before we start, can I have a hand? Okay, so you can just use the raise hand button if you actually downloaded the Poll Ev or Poll Everything application on your devices, or at least you open it on your computer. Can you guys just use the raise hand button so that you don't have to say yes or no, or say anything? Can you guys? Please, I'm hoping that you guys are here. Are you guys here? Again, okay. Izzati, anyone else other than Izzati? Is there anyone else who actually downloaded the Poll Everything app? Okay, all right, good. So I'll see a few more. Okay, now, thank you. So what I'm trying to do is, instead of me talking to you guys, just talking by myself, you guys just listening. So what I'm going to do is, part of the lectures will have some questions, and then you can just open your Poll app on your mobile, like what I'm doing now. Okay, and when the time comes, I will activate the questions and it will pop up on your mobile. Then you can answer it from there. So instead of me asking one by one, what do you think? What do you think? Or you guys just listening or probably doing something else, hopefully not. So we will have some interaction, okay? But interaction in class, face-to-face is easier, but because it's online, so I'm trying to find an alternative that I'm hoping that we'll be able to at least do something similar. All right. So if you don't know about me, so this lecture, this slide is just about me a little bit. I like to be called as Hadi Fuad. Okay, I did my bachelor's degree in Bachelor of Biotechnology in Chemistry, so that's why I'm teaching you guys about peptides and proteins. So this area is actually my research area. So this is what I've been trained for. This is what I'm focusing on. Okay, and I skipped my master's. I straight away did my PhD in medicinal chemistry, also in Australia back in 2005. Also, it's actually more than 6 years ago where I completed my PhD. And I work at a few different places, learning about various other things, but mostly they resolve around the using of peptides and proteins. Okay, if you want to learn more about my backgrounds, my research work, if you're thinking about planning about your FYP next year, for example, you can just go to this website and pretty much I have all my information there. This is just a picture when I was doing my postdoctoral. Okay, so course introduction. If you have looked at the your spectrum, okay, so your spectrum currently only have the cost pro forma. So this is this table was extracted out from cost pro forma. We normally put in two files. One is course performa, one is course information. But the course information is not updated yet because previously, normally this course was handled by Dr. Ikramul and Dr. Dini. But this time around, because Dr. Dini is expecting a baby sometime in, if I'm not mistaken, in May. So I was tasked to take over the course. So of course, all the lecture notes will be new. It won't be similar to if, say, you took a lecture notes for this subject from your seniors, especially for Dr. Dini's section, then it will be totally different. Okay, I will not be touching about what Dr. Dini is doing. I'll be touching about what I'm expert of, what I'm expert in. So that's what you guys will be learning. Okay, so if you focus on this section a little bit, the course outcome is basically for you guys to be able to explain various special topics in depth. Okay, so instead of just going on a very a broad area, it will be going into a bit more detail. So that's why I'm hoping that, I haven't checked, but I'm hoping that most of you guys have at least gone through SID3004, because on that course you actually learn a little bit about proteins, and of course, if you're talking about proteins, then it's almost similar to peptides. And the course learning outcome for the second course learning outcome is you'll be able, I'm hoping that you guys towards the end of the course will be able to analyze the importance and advancement of the particular topic. So you will see soon, I will talk about what are the subjects or the industrial aspect of peptides and protein that I'll be teaching. Okay, there will be a lot of critical thinking and problem solving skills. Of course, especially during your final exams, during quiz and whatnot. So we'll reach there when we reach there. Okay. So for this course, the continuous assessment is 30%, and your final examination is 70%. And of course, these two information is not just for me. So if you divide this into two, okay, so 50% will come from me, 30 and 15 and 35% will come from me, and then the rest will come from Dr. Ikramul. Okay, and in my case, your final exam, I've looked through the comments that the chemistry students posted to, well, Dr. Mas and probably Dr. Rosie. Okay, and most of you guys prefer to have your final exam during the final exam week. May I ask if you guys are in that particular group? Do you guys prefer to have your final exam during your final exam period, or you prefer to have the alternative assessment? Can you just say yes if you prefer to have your final exam during the final exam week? Is anyone here? I'm hoping that I'm not talking alone.
Yes, doctor.
Okay, thank you, Mas. Okay, I'm hoping that you guys will be more interactive. Okay, so let's focus a little bit. So if you prefer to have your final exam during the final exam week, then this is what I'm planning to do. Okay, but again, towards the end of the day, what I'm planning doesn't mean that it's a guarantee, because towards the end of the day, the faculty will dictate whether, at least for this semester, the faculty will dictate whether this subject will be able to do it as a final exam or not. Okay, so that's what will be the alternative assessment. So normally the alternative assessment that I give is an open book type. Okay, so open book type, and I would say it will be difficult because it's an open book. For final exam, it's a closed book. Then it will be so. I'm expecting what you have learned only, but open book, I'm expecting more than just what I'm teaching during the lectures. Okay. Now, but so far my plan is to do it during your final exam. final exam week, meaning you will have a full 14 weeks of lecture. Hopefully we don't have any holidays. Otherwise, I need to re-plan all the lectures. But if you don't have any holidays during on Monday throughout the next 15 weeks, then it's all good. Okay, so 35% final exam during exam week, and 15% because I have yet to see Dr. Ikramul's planning. So far, I'm planning to have two quizzes. Okay, one is
Doctor.
yeah.
Can I ask? So when you say open book exam kan, is it like based on what we learn, macam typical exam ataupun macam report?
It will be like a report.
Oh, okay.
Okay.
Right.
But of course it will not be a totally unrelated to the lectures. It will still be related, but you know, I'm expecting more information because it's an open book. Okay. So that's why this semester at least I'm not opting for an open book test, because I understand your limitation studying at home. I understand your maybe you have some problems with your internet connections, limited internet connection. So I'm opting for a final exam type assessment. Okay. All right. So going back to your continuous assessment, I'm planning to have two quizzes. So one quiz will be on the 7th week, another one will be on the 14th week. Okay, so you will have quiz 1 and quiz 2 from me. It will be on Monday and it will be during lecture time. All right, but I'm not sure how Dr. Ikramul is planning his continuous assessment. If say he is planning for quiz as well, so towards the end of the day, I might combine my quiz with his, so that you don't have to spend so much time, you know, answering all these quizzes again and again. I understand the limitation. Okay, but this is at least the plan for the assessments, at least for my side. Okay, lecture arrangements. I'll be conducting 7 synchronous lectures. So this is one of them. That will include tutorials and discussion. Of course, it depends on whether you guys are interested in doing some discussion. Last semester, I had a request from one of my classes. They prefer to have a discussion after a quiz. Okay, so it's up to you guys. If you want, then I will include it as part of. I'll try and squeeze in the discussion bit probably along this week. Fortunately for that one, we cannot do any discussion unless if you guys want to do it following week 14, so on week 15 or during weekends, then we can try and adjust it. But otherwise, if there will be a discussion, then there will only be one discussion on that particular week. Additionally, we will have 7 asynchronous learning. It will be 5 lectures and 2 tests. Okay, so the 2 tests is this one and that one, as I mentioned, week 7 and week 14. And for this asynchronous learning, what I'm trying to do is to also add some activity. So meaning that I will not be just recording lectures and then post it on Spectrum or YouTube and then just leave for you guys to, you know, listen to it at 2 times speed. So what I will be doing is I will record a lecture, something like this, and then I will put the lecture lecture recording on Spectrum. And then Spectrum has this feature to for the lecturers to embed questions during the lecture. So that is what I'm planning to do. I'm hoping that Spectrum will not cause any trouble. Okay. So 5 recorded lectures, and along the lectures there will be some quizzes, questions, kind of like an embedded tutorial within the lecture itself. So by doing that, I'm hoping that you will not be too bored by just listening to videos. All right, so I've talked about those two. Again, this is just a pre-plan. I will need to look at how Dr. Ikramul is planning his lectures and assessment, and it might be adjusted. Okay, so this is what I'm planning the lectures to be. And as I mentioned, final exam during exam week, hopefully you have ample time to at least do a revision from the first lecture, which is today. Okay, so throughout the lecture, you will see this guy, okay, smiley face with a star on his eyes. It is an indicator that some information were taken out from the lecture notes. So if you notice that if you downloaded the lecture notes and printed out or at least viewed it, so you will notice that there are a few lectures with this smiley face guy over the top right hand side of the lecture. So it means that you actually need to do something instead of just listening to whatever I'm saying. So you need to at least open your PDF and type in some information, because there are some information that I took out purposely so you will not feel bored listening to a lecture, and you can do some activity as well. Okay. And attendance link is available, not yet on Spectrum, but I have it at the end of this lecture. Okay, so we'll go through there once the time is right. But I will post the link on Spectrum, and what we will see is every week or in every lecture, I will post a code. Okay, so this is your code for today. When you do sign in for your attendance, you need to put in this code as part of the online attendance. If you did not put it in, then I will consider that you are actually absent from the lecture. Okay. Now, it's the same for pre-recorded. So pre-recorded will have their own code as well. So if you have watched the lecture, then you will know what the code is and then you put it in. So I'm not doing this just for fun. So this is actually to encourage you guys to actually look at the lecture notes, or at least to listen to my recording. Because based on my previous experience for the past 2 semesters, there are students who actually did not listen to my lecture notes or lectures and then try to answer the final exam. Okay, if you do that, I can guarantee you that you will not be able to do it. You will not be able to answer the questions. Even though sometimes the questions are very easy, but because towards the end of the day during final exam, what you might do is you will just Google the particular topic, then your answer will not have the same keywords that I'm giving out during the lecture. Okay, so please watch all the recordings. It takes our time to actually prepare the lecture, prepare the recording. So I'm hoping that you guys can spend your time to actually listen to it as well. Okay, so let's go back. Let's move to the lectures. So what I'll be doing for today is to actually do a revision. Okay, it's not a new lecture. Hopefully it's not a new for you guys. Hopefully it's kind of like a revision. But this will serve as the basic for all the technologies that we'll be discussing throughout the week. I wonder, I think one slide is missing. There should be a slide on the, let me see. Oh, I think I did not put it in. Okay, anyhow, I'll just open it very, very quickly for you guys. One, of course. Okay, because I was told that I need to show this to you guys. So I'm showing it to you guys. Let's see. Present window channel. Okay, so this is the plan for your lectures. Okay, first week for today it will be a synchronous introduction of peptides, proteins, and industry a little bit. Next week we'll look at synthetic proteins and peptides. So this will be related to how industry produces proteins and peptides. Number 3, more on rapid diagnostic kit. For example, COVID-19 kit, HIV kit, and so on and so forth. Week 4 will be asynchronous lecture. We're talking about vaccine technology. So we heard that Musti Minister YBKJ talks a lot about vaccines and whatnot. So what are actually vaccines? So this is this lecture, I'm hoping that you will understand a little bit what vaccine is, how we, or me as a chemist, how do we actually produce a vaccine. And then on week 5, the idea is for me to introduce some future technologies related to peptides, which is MOF peptide. MOF stands for Metal Organic Framework. It's a new technology that, well, we'll go to it later on, so I don't want to talk about it. On week 6, we'll have some discussion or tutorial, or we can probably swap these two. So quiz first and then discussion later. It depends. Okay. On week 8, we'll learn about HPLC analysis on peptides and proteins. So this one is specifically for peptides and proteins. So it'll be more kind of like focus. So you might have learned about HPLCs or mass spectrometry or NMR, but when you utilize the systems for peptides, there are slight variations. So we will learn about it in a bit more detail. And then on week 11, again, we'll have a tutorial or a discussion. And week 12 and 13, we will have a panel talk. So the idea is to introduce you guys not just about technologies, but also to understand how this technology actually comes about. Okay, so you learn a little bit about intellectual properties and commercialization. And on week 13, we will have another industrial talk. Hopefully, I can manage to get my colleague to talk about a little bit on regulation and registration of new products by the NPRA. Or probably, if I can't, then alternative is for you guys to learn a little bit about QA/QC, okay, quality control, quality assurance, and quality control, which is related to good manufacturing practice or GMP. Now, why do I want to do this? Because I understand that QA/QC subjects are not not compulsory for you guys. So when you are doing your internship later on, your work might be related to QA/QC or probably GMP. So by knowing this information a little bit, I'm hoping that it can give you guys some add-on information about QA/QC and whatnot during your internship. Okay, let's move back to the lecture slide. Okay. Now, so I've just talked about this a little bit. So this one is just the industrial. What are the industrial applications that the lecture will be focusing on? So one is a rapid kit. So everybody knows, or at least you have heard about COVID-19 rapid test kit. So what is it all about? So you know it's a kit. You know that you might need a drop of your blood or a drop of your saliva, depending on the kit. Okay, but how does a kit actually works? Yes, you can just Google it to find the answer. But again, you can pretty much Google everything. But I still need to talk about it in the lecture. Okay, so first one, we'll look at rapid kit. Second one, we will look at vaccine technology, how you develop a vaccine, and why is it actually very difficult to produce a vaccine that is safe for everyone to use. And the third one, we will look at TruePic. Okay, so at least this is the plan. TruePic is a company that sells the MOF peptide that I mentioned previously. Okay, not MOF peptide, it's more on MOF technologies. Okay, so MOF is a very, very new technology. It's very recent, even though the research and development have been going on for so long, but this is so far the only company that produces MOF products that is commercially available. Okay. Now, I actually have it here. So the outlines of the topics, of course, just disregards on the weeks, because a week is just for planning. I might jump over into a different week by talking just one simple topic. Okay, so if I did do that, then whichever was not touched during the lectures will be excluded out. All right, for example, something that I've seen that can be combined is HPLC and MS. So you've seen previously on the Word document that I've shown, HPLC will have one lecture on its own, MS will have one lecture on its own, and NMR will have one lecture on its own. But HPLC and mass spectrometry can actually be combined into one lecture, provided that you understand how HPLC and mass spectrometry works. If you do understand that, then it's very easy. I can just combine them into one lecture, and either I will touch more about the technologies that is available in the industry, or can focus more about peptide NMRs. Okay, because peptide NMRs are totally different than your normal organic NMRs. Okay, totally different. And even for me, when I actually learned about peptide NMRs, there are some difficulties initially. Initially it's very, very difficult. Now it's still difficult, but we get hang of it. Okay. So the topics are introductions, and then next week synthesis and biosynthesis of peptides and proteins. We look at two different systems. One is a total synthesis in the lab. Another one is how industry actually produce peptides and proteins. Of course, it's going to be a bit brief because talking into details, that alone might probably take about 2 or 3 lectures. Okay. And then we looked at, again, rapid diagnostic kits. We looked at vaccination and some future technologies that I'm trying to hopefully be able to touch is the metal organic framework, or MOF. Okay, so that's why I put it there, KIV, because I'm not sure whether we will have time. That's one thing. And then second thing is I have yet to check if we actually have a holiday on Monday for the next 15 weeks. If you do have holidays, then I might need to cut some of this topic off, but I'll try and see if we can actually cover everything. Okay, and on week 13 and 12 and 13 is about regulation and intellectual properties and commercialization. Okay, now you'll see the first guy. Okay, so if I can have everyone to open your, it's automatic. Open your poll app. Okay, so this is the question. What is a protein? If you can answer it very, very quickly. So I want to see if I can actually see the feedback live or not. Okay. Wait, this is what is a peptide? This is the wrong question. So I'm activating this question, what is a protein? If you have downloaded the app, please join in by using that keyword, okay? Hadi Fuad 049, okay, that particular keyword. Oops, oh, I cannot put it there. So Hadi Fuad with double A 049. Okay, there you go. We have answers now. It's live. Okay, so this is how I'm hoping that all the lectures will be something like this. There will be polls, there will be questions, and obviously it will be anonymous. So by all means, join in so that we'll have more answers. Okay. All right. So we have 1, 2. Oh wait. Someone choose none of the above. Okay. All right. So I'll wait for 10 more seconds. So there's 2 people who probably chosen none of the above. Okay, 10 more seconds. 5, 4, 3, 2, and 1. All right. So thank you. Okay, so what is protein? What is a protein? So of course, 86% normally shouldn't be wrong. Yes, the answer is correct. A long chain amino acid connected via amide bond. Okay. Oops, I was pointing using my mouse. Short chain polyacrylamide connected via ester bond is wrong. One is because a protein connects via amide bond, so it's never an ester bond. Okay. And second one is because it's not polyacrylamide, it's polyamide if you want to change the words. Okay, so it's polyamide, not polyacrylamide. Acrylamide is something else. You can search for the structure of acrylamide, so it's not close at all to an amino acid. Okay, those who actually choose none of the above, you are also wrong because the answer is a long chain amino acid. So the first guy who actually chosen none of the above is actually me. So I just want to confuse you guys. But anyhow, okay, thank you for participating. Now we have our second questions, which you guys have already did. Okay. So I have 4 responses now. I'll give you guys about 15 more seconds. Okay, 10 responses, 11, 12. Okay, so if you like this system, I will have more questions next time. I probably should have a question about this question, whether you like to use this system. Seems like it's fun, right? Okay, 5 more seconds, 4, 3, 2, and 1. Okay, I'll close it. Okay, so what is a peptide? A polyamino acid. Second option is a shorter version of a protein. Okay, so this is a trick question. Both are actually correct. Okay, so these are some of the types of questions that you will have for your quiz. Okay, this is the type. I will make you confused, but there are actually more than one answers. So what I'm trying to convey is for you guys to be confident. So be confident in your answers. Do not discuss. Do not follow your friends. As long as you are ready, you know that you did your revision, you did your studies, you listen to all the lectures. You should be able to at least answer questions like this. Okay. So none of you guys are actually wrong. The option A and option B are actually correct. Okay. Question 3. Oops. There should be a picture of something behind it. Let me see if I can actually show it to you guys. Keep everything. Make it smaller. Where's the picture? Oh no, the picture is gone. The picture is gone. Never mind. Okay, we'll skip this question. Okay, so there's supposed to be a picture asking you which one is the beta plated sheet. Never mind. We'll play this one again next time. Okay, so a bit of a revision in terms of the lecture. So pretty much you guys did well for the revision. You guys, I'm hoping that everybody, even though it's not everyone, so I managed to get 21 responses. There are 29 of you guys today. Okay, so I'm hoping that the 8 of you are actually listening or at least know what I'm talking about or what your friends are trying to answer. Okay, so those 2 questions are basically the general idea about peptides and proteins. Okay, so initially you have your amino acids, and then from amino acid you can build up peptides. Okay, in this case, what is shown here is a dipeptide. It's 1, 2, 3, 4, 5. It's a pentapeptide. So how do I know it's pentapeptide? I'll look at this blue thingy. Okay, so blue is nitrogen. Nitrogen divides between one amino acid to another. So because there's 4 blues, so there's 5 amino acids. Okay, so it's a pentapeptide, and then if you grow the peptide even larger, you can build proteins or enzymes. Okay. So basic information that you guys probably have also seen is that DNA makes up or builds up mRNA, and mRNA builds up proteins or polypeptides or peptides. Polypeptides, peptides, or proteins. Okay, so why do I want to talk about mRNA? Why do I want to talk about DNA? Because when we are talking about the vaccine technology, everybody knows, or I'm hoping that you guys have actually read something or somewhere, that Pfizer vaccine, for example, is an mRNA vaccine. Okay, so this is how it's related, and this is how I want to focus on the word mRNA. Or this is the reason why I'm putting mRNA as part of this slide. Okay, mRNA. We will look at the mRNA in more detail, but for today, we'll just focus a bit more on peptides and proteins. All right, so amino acids, there are 20 naturally occurring amino acids as listed here. You have different groups of amino acids. For example, on the left hand side, you have an amino acid which are electrically charged side chains. Okay, meaning that the side chain can have a positive or a negative charges. Okay, so you have 3 that can have a positive charge, and then 2 that can have a negative charge. Okay, so these are important in some ways, but if you forgot about it, then just go back and listen to SID3004. So today's lecture is just to fast forward and go to hopefully just give a bit of a basic for you guys, just to recall enough information to actually understand the technology that I'll be trying to tell you guys. Okay, additionally, we have uncharged amino acids, which are just polar. Okay, we have special cases whereby you have a thiol group that can form a thioester. Selenocysteines are not part of 20 naturally occurring amino acids, so I'll just cancel that one out. You have a glycine over here, which does not have a polar group at all. And we have a proline here, whereby the amino group is not a primary amine anymore. Additionally, we have more amino acids which are hydrophobic in nature. Okay, so those are the amino acids. Again, amino acids, you need to know the name, and by knowing the name, you need to also know the 3-letter code. Okay, for example, 3-letter code over here is this. So that is the name, lysine, for example. 3-letter code is LYS. And a single letter code, which is just K. Okay, so those are the 3 things that you should have. I'm hoping that you guys can recall a little bit. Okay, so a unique feature of an amino acid is that we have 20 naturally occurring amino acid around us. Okay, but this information is no longer very accurate because there are some amino acid that is being produced by bacteria and some other microorganisms in the ocean that are covering the amino acid as well. Okay, so we have essential and non-essential amino acids. So essential amino acids are amino acids that we human cannot produce on our own. Okay, so those are essential amino acids. Non-essential amino acids are amino acids that we our body can produce the amino acid by using a different source. For example, if you eat a protein, the protein can be digested, can be absorbed by our body, and it can be converted into a different amino acid. Okay, and amino acid also has is a chiral molecule, so you can have a L and D amino acid. I leave it to you guys to recall what is L and D. I'm hoping that you guys can still remember what's the difference between L and D. Okay, and the unique feature of an amino acid is the R group. So the R group, as shown in the previous slide, are unique. Okay, there is no amino acid that has 2 of the similar R groups. And additionally, each R group has its own pKa's. You can go to this link to look at the values of the pKa's. Again, I'm not gonna describe about it because it should be part of your second year SID3004 lecture. Okay, polar and non-polar charges as also shown in the previous slide. Okay, so how do you distinguish what are the barrier between definition of a protein and a peptide? This is how I like it to be. Okay, so peptides are normally short, and normally it has less than 100 amino acid. So anything that has more than 100 amino acid, I normally consider as a protein. But again, this is kind of like a gray area because there's no dictionary that actually justifies what is a peptide, what is a protein. It can be interchanged. But proteins compared to a peptide are normally longer, but no exact number. Okay, for example, the structure on the bottom right hand side that you've seen is actually an insulin. Okay, insulin is a protein, but it only has, if you count that one, 30 plus 21, it only has a 51 amino acids. So if you just consider based on the number, then you might say, oh, insulin is actually a peptide. It's yes and it's a no. It is a peptide because protein is also a peptide. But it's a protein. Why? Because a protein, all enzymes are protein, but not all proteins are enzyme. Okay, so because insulin is an enzyme, therefore it's a protein. All right, so that's a clear definition of at least it's my definition of peptides and proteins. Okay, so we have seven minutes to go, and I still have a few more lectures slides. So again, peptides and proteins can be a micromolecule. It can be huge, and of course, it's normally huge when compared to other organic, for example, organic solvents or organic molecules that you guys learn in your third year lecture or probably on the second year organic lecture. Okay, so it's huge, it's very big. And as I mentioned in the previous slide, the terminologies are a little bit interchanged. Okay, so proteins are normally a biological entity or biological micromolecule that have a certain function for the host. Okay, for example, an example of function is a catalyst. It can be a transporter where it transports molecules in and out of the cell, or it can be used as a digestion. For example, in your stomach, we have a peptidase. Okay, peptidase where it digests out all the meat, chicken meat or beef meat that we all eat. It will digest it. Or it can have something that insulin that catalyzes an activity. Okay, for peptides are normally non-host functions such as a protection. So in our body, we actually also produce peptides. So they are not proteins because it doesn't have a specific function to help our cell survive. But the peptide is used for protection. Okay, so the peptides are called as AMP, antimicrobial peptides. So we have it in, for example, in our teardrops. Okay, so that's why as contrast to our skin, a skin is a barrier, but for our eyes, we don't have a barrier, a solid barrier like this. So our body produces these AMPs as kind of like a protection from bacterial or microorganism infection. And also, again, all proteins and peptides have a unique three-dimensional structures, as shown over the bottom hand side. Okay, even if you normally see structure in a cartoon representation, like this one, the one inside here, where you can actually see where is the alpha helices, where are the beta sheets and whatnot. But you need to remember that this structure, the cartoon representation, are normally just based on the backbone of the proteins and peptides. So if, for example, the protein has a side chain, you normally don't see it in the cartoon representation. Okay, for example, if you focus on this section over here, okay, you can see that the backbone are actually kind of like forming a C shape. Okay, a random coil, so to say. But if you're just focusing on the cartoon representation, you do not see the three-dimensional shape that particular amino acid have. So that's why it's very important to understand that even if you are looking at a cartoon representation or stick and figure representation or ball and stick representation, they are actually a three-dimensional shape on a protein and a peptide. And these three-dimensional structures or shapes are very critical in all the technologies that are involving the use of peptides and proteins. And we will see more when we get to either the vaccine technology or the rapid kit technology. Okay. All right. Oh, the question becomes here. So this was supposed to be the third question, but never mind. We'll just skip it. I'll just, because we don't have enough time. Okay, so secondary structures, again, this guy, so those things are blank. If you don't recall, then please by all means write it down. We have three main secondary structures that are widely written in all textbooks. So we have alpha helix, we have beta plated sheet and coil. We also have more than that. We have variations of alpha helix, and also we have variations of beta plated sheet. We have parallel, anti-parallel, and so on and so forth. Okay, you probably listen that. Notice that I'm talking like very, very quick because I'm trying to catch on the time. Okay, so and also we've also touched about the various forces that holds proteins and peptides together. So it's kind of like it's more dynamic molecule. It's flexible. It's not really a rigid molecule. Okay, so these are some of the forces that we've also gone through in SID3004. Please, if you don't recall all these forces, go back and do a revision. Okay, I'm not gonna spend time to actually talk about it since it's already been discussed previously in your SID3004. Okay, and also we the flexibility or the dynamics of a protein comes from a few models, a few theories, which we have touched a little bit, especially for number 1 and 2, lock and key model by Emil Fischer in 1894. We also looked at the induced fit model by Daniel Koshland that was proposed in 1958, but those two were not discussed, and again, it will not be discussed in this lecture. It's just as an information for you guys to, if you are interested in proteins and peptide technologies, to actually go into these two theories and kind of like have a look and learn about it. Okay. So the most important thing is, never mind, it's already 2:50, so I will continue about this next week. Okay, I don't want to move over and take more of your time. So we'll continue this next week, and we'll also start with our lecture 2. Okay, thank you for your participation. I will upload this lecture on YouTube first, then I will post the link on Spectrum in case if you want to do a revision in the future. All right, so thank you, and see you guys next week.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.